folks, welcome back to the last part in the 5.1 video series. So we're going to be talking about applications of area approximation. We're going to go through an example and talk about how you might do this other than just graphing a bunch of points and what it might be used for. So in question 9, we have that the speed of a runner steadily increases during the first 3 seconds of her race. Her speed at half-second intervals is given in the table. And so we see here that we've got time for our x values and we've got velocity for our y values. And so let's take a moment to think about the idea of velocity and distance, okay? So if we go here, I'm going to go above just to write it here, but if we think about what we know about position, I know if I take the first derivative, I get velocity, and if I take the second derivative, I get acceleration. But what we're going to start to see here is that if I have velocity and I go backwards, so I find the antiderivative, it will actually give me position, okay? So we can say that the derivative of position equals velocity, but we can also say that the antiderivative of velocity equals position. Okay, so those two pieces definitely go hand in hand. The derivative will help you find some things, and sometimes you need to go backwards and find the thing it came from. And so that's what we're going to do in question number 9. Okay, so question number 9 says find the approximation using 6 rectangles. So LRAM means that I need to take my b minus a and cut it into 6 equal pieces. And then I'm going to take the first endpoint plus the second one plus the third one plus the fourth one plus the fifth one plus the 6th one. Okay? So that leaves me with all of the y values except the one for the last one. And that's how LRAM works. Okay? So let's calculate this a little bit. I didn't leave myself very good space here, but that's okay. So b in this case will be 3 minus a is 0 over 6. And I will just take the y values from the table. So 0 plus 6.2 plus 10.8 plus, that's supposed to be 14.9 plus 18.1 plus 19.4. And let's see what that gets us. So I have 0.5 times 0 plus 6.2 plus 10.8 plus 14.9 plus 18.1 plus 19.4. And that gives me 34.7. But 34.7 what? This is actually an approximation of the distance that she's gone in 3 seconds. Okay? So this is the distance she's traveled in 3 seconds. An approximation of it. Well, let's find our RRAM using 6 rectangles. I would follow the same formula, except for LRAM, which I think we've been doing in the orange, we took these 6 points. But for RRAM, which we've been doing in the red, we want these 6 points, okay? And the height of each rectangle is actually going to be the same because I'm looking at the same interval and they're cut into the same number of pieces. So I'm going to have 1/2, which is the 3 over 6, times 6.2 plus 10.8 plus 14.9 plus 18.1 plus 19.4 plus 20.2. Let's see what that gets us. 6.2 plus 10.8 plus 15.9 plus 18.1 plus 20.2. And that gives us 35.1 feet. And again, this is an approximation of the distance that she's traveled. Now, based on looking at this, because the first value is 0, I'm betting that the LRAM is an underestimate and the RRAM is an overestimate. Okay, but without an exact graph, I don't really know. All right, let's take a look at MRAM. Now, things are going to be a little different for this one because we're looking at 3 rectangles, okay? 3 rectangles. So, 3 rectangles means B, which is 3, minus A, which is 0, over 3, not 6. Okay, so that means that I'm going to need to pick the middle of each of the 3 rectangles. So one rectangle starts at 0 and goes to 1. So the halfway number is 0.5. So I want to use f of 0.5. Plus, the second rectangle starts at 1 and goes to 2. So the middle one is f of 1.5. Plus, the last one goes from 2 to 3, and the midpoint there is 2.5. And so we get 1 in the front here. We get 6.2 plus 14.9 plus 19.4. And let's see what that gets us. And that gets us an area of 40.5 feet that we think she's traveled. And again, that's an approximation of the distance she's traveled. All right. Last but not least, find the trapezoidal approximation using 3 trapezoids. So we're going to take our formula for the trapezoid, which is a little different because it has that 1/2 in the front. Okay, so 1/2, and then B minus A over N, which is 3 because I want 3 trapezoids. And then I'm going to pick the start Y value. That only counts once, plus the 2 times the second Y value, plus 2 times the third Y value, plus, oh, we're at the end, so only 1 of the last one. So this is going to give me 1/2 on the outside, f of 0, 0, plus 2 times 10.8, plus 2 times 18.1 plus 20.2. And let's see what that gets us. So 2 times 10.8 plus 2 times 18.1 plus 20.2. And that gets us about an area of 39, which really represents 39 feet. In terms of the distance that she ran. Okay, so this is one way that when we have information about velocity, we can figure out the information about her distance. All right, let's do this second example real quick where we're looking at the speedometer of a car. So again, we have our time as our x value, and we don't have distance, but we have velocity. And so if we find the area under the distance curves, we will get if we find the area under the velocity curves, we'll get the distance curve. Now, I'm just going to set these up to make sure that we have the right setup. I'll leave it up to you to type the numbers into the calculator. But let's get started. So LRAM, I need B 30 minus A 0 over how many rectangles do I want? I want 6. And because I'm looking at LRAM, I'm going to do f of 0 plus f of 5 plus f of 10 plus f of 15 plus f of 20 plus f of 25. and that will be, if I plug in all the values, that will give me my left rectangular approximation. If I want to find the right one, I'm still going to do b minus a over n, but I'm not going to use the first y value. I'm going to use the second one, the third one, the fourth one, the fifth one, the sixth one, and the seventh one. Okay, so I shift everything by 1 to find the RRAM. To find the MRAM, I'm asking for a different number of rectangles. So I'm still going to do b minus a, which is 30 minus 0, but this time I'm going to divide by 3 because that's the number of rectangles I want. And then on the inside, I'm going to have, let's see, what's halfway between 0 and 10 is going to be 5. And what's halfway between 10 and 20 is going to be 15. And what's halfway between 20 and 30 is going to be f of 25. Okay? And last but not least, we're going to find the trapezoidal approximation. So I got to remember that 1/2 in the front. I've got b minus a over n. And when I count for the 3 trapezoids, the first number and the last number only get counted once, but the ones in between get counted twice. So f of 0 plus 2f of 10 plus 2f of 20 plus f of 30. And if you use all the values from the table, you should get the right approximations for all of these, okay? But if you think about an exam, I would be more concerned that you can do the right setup like we're showing here than just to type in all your numbers and hope that you type them in correctly, okay? So make sure that you show me these steps, like what did you plug in, all right? So that way I know that you really understand the process that you're going to be using, all right? So that's it for 5.1. If you have any questions, send me an email, shoot me a message on Canvas, send me a message on WebAssign, and I will be happy to help you out. All right, thanks so much, folks. See you later.